Good afternoon, very late afternoon, everyone. My name is Nicolo Dell'Unto, and I work at the Institute of Archaeology and Ancient History at Lund University, and I'm currently coordinating the scientific activities of the DARC lab, the Digital Archaeology Lab, which we have at Lund. We work a lot with, we're very much interested in understanding how visualization is changing our way of perceiving archaeological information, and we're very much interested in archaeological results. So what we do is really focus in answering research questions more than, let's say, developing and so on. But today I would like, divide the presentation in two small parts. The first one is about 3D models. I mean, what are these entities and how those should be considered in relation of what we search or what we document. And another one is about some case studies which display some, of our results of consideration and so on. So we know that, 3D model can be defined in many different ways, and a definition I like is a summary or simplification of a physical thing. But the reality is that we have very different typology of 3D models, and very often the idea is that those can be substitute drawings, but this is not true. I mean, every typology of data has its own affordance, I would say, or properties, and we think that all of those can really help us in documenting and highlighting specific aspect of it. This is interesting. This is a slide which displays a case study, very old case study in 2012. We were out in a field, and in basically half a day, we were able, just using image-based modeling, scanning, of producing a huge amount of 3D models of different type of archaeological evidence retrieved during excavations. And the first thing we figured out was that, well, this is too much. I mean, this is really, this morning, I think, there was a presentation talking about big data. These are big data and complex data. So there is really complexity also because they don't, they are not designed actually to fit our normal traditional visualization system. So in order to make something good with those, we need to, I think, challenge our paradigms or how we use information. We have been experiencing a lot with 3D GIS platforms, but there are many different typology platforms which, help you out in using this data. There is Blender, to augmented metrics, for example, with the Metresco. We have someone used Unity, and all these platforms, they actually resemble very different characteristics. Of course, a 3D model, when it's actually visualized into, for example, into a 3D GIS, allow you to, as an archaeologist, to use the model and running a huge number of operations, which would have been impossible to do in any other way. We decided to go for 3D GIS because it allowed to use our models in relation of more traditional documentation, which very often is everything is left on a site. Like, for example, in Pompeii, we have a lot of very good documentation which has been scanned, and we need that in relation of our models and so on. But still, it's not really the only solution. There are many. You can, compare drawings, you can run statistics, you can make measurements which are difficult to perform in the field in any other way. But most important, they don't really substitute your work in the field. They actually implement your work in the field. You use that in a tablet, for example, and you can get a huge amount of information. But visualization and 3D model are not the problems, really. Are only one part of the facade. There's been a huge discussion about, you should develop a different database. This is the best database. This is the best visualization system. You should change. This is not sufficiently enough for the standard. Well, but the reality is that for our experience, we have been trying this in many different archaeological excavations, really using a combination of GIS and 3D models in different situations, which goes from building archaeology, classical archaeology, to prehistory and so on. And the final consideration is that you need to adapt. There is no system which fits for everything, and we've been finding ourselves in customizing our database or our way of moving in the field or really catching the information in a way that's in other case studies didn't work so well. So it's interesting because with technology we have flexibility, something that it doesn't really fit well with the standardization of data. So. And for example, in this case, it's the case of Schemping. It's an excavation which we've been recording this for 4 years, excavation, completely in 3D. We only use 3D models or 3D surface models. As a palimpsest, we're recording in 3D our information. The database was customized in order to, host the information from the excavation. And most important, what was interesting is that this site, for example, was very special for the artifacts, and because many of the contexts actually were disturbed. So we didn't have so many specialist in lithics artifacts in the field. And you will know, usually you have one, if you're lucky, one or two in the field excavating. Otherwise, you analyze them once back. But in that case, we could produce actually reference collections for the students or for archaeologists working on site, and actually eventually giving the possibility of better understanding the artifacts or what were they encountering during the excavation directly in the field. This typology of approach, it's very much interpretative in many senses. For example, when creating the model, you analyze the context, you make a 3D. The 3D acquisition is actually subjective per se. The way of how you take the picture, which kind of light you decide to use, the way of how you move if you're using a scanner, how many scans you're taking, this is definitely a choice of the operator. So subjectivity is not a bad thing. It's actually a very good thing if you know how to do it. So that's also the big risk, having a model with a couple of clicks. It's not the same. The majority of these models really not really good because they don't display the research question of the single researcher. But if you know the way over you're using it, what you can obtain from them, the results are great. The 3D GIS implementation, when it's in the field, is not a matter of interpretation, I would say. Eventually, it's happened before. But then also the 3D drawing, when we 3D draw on the models for highlighting what we think should be, highlighted in the context description is also part of the way of actually archaeologists perform their operation in the field. And this changes all the time, in a sense, and very often reflect the research questions. This is really the core or my point. What I'm trying to say is that focusing the discussion on databases, tool for analysis, I'm using a better instruments and acquisition methods is not going to work. Because the reality is that all these things are completely connected. I mean, the kind of instruments you're going to use are going to define the typology of model you are going to make for actually being visualizing the type of system you have at that moment. Because this is how it is. So it's very interesting, the fact that this is very fluid, it's dynamic. And I think, there is no standardization that we can look into it. And I don't think it's actually the real direction to take. Because standardization very often kills what is the creativity of the research process. I think a good conclusion was in a very interesting edited volume from Eder Rissetto and Fabrizio Galeazzi, when they, basically in the introduction of this, they conclude that, instead of going for standardization of software, tell me if I'm wrong, Eder, actually the idea of creating output or standard which can be shared is a much better solution. Is it very wise? Because actually allow us to be flexible and do what we need at the moment to do it. So this is very important. This is what when it's about stratigraphy, how do you document your stratigraphy? How do you go through the excavation? Well, it depends on what actually you have and what you want to achieve. But actually this goes very much behind these possibilities. We've been experiencing a lot also with volumes. Well, another thing that I would like to share with you, is the fact that we tend to think when it's about 3D models that, it's like a linear evolution, like a human evolution, like a point, a polygon, a polyline, a bundle bond model, a surface model, a volumetric model, like if one is the evolution of the others. I believe this is not absolutely true. There are actually things which you can do with volumes, which you cannot do with surface model, and vice versa. We should think that actually the volumes are very much often infer conclusion. So you never see it. When you excavate, you spoil actually the excavation. And I've seen a very interesting paper of Peter Jensen about that you create a stratigraphy going layer by layer, but it still is a different approach. It's a surface approach. The only technology which they give us the possibility of visualizing volumes for a direct acquisition tool is geophysics. And this actually can be definitely visualized as a points cloud and volumes in the GIS. And it's fantastic because they come with intensity values. So, but all the others are infer, actually, which is not bad at all. But you should not, you should take into account of that limitation in a sense. as well as surface models as well. They have the same characteristic of polygons. So it's more about the affordance of the models which make the difference, and not the type of model per se. This is a fantastic case. This was actually this is Stora Forvari. Is a prehistoric cave which was excavated in the 19th century with split layers. So no stratigraphy. It was fantastic because by scanning basically the cave and using the documentation of the split layers from the archaeologists at that time, it was possible to reconstruct the volumes of it in many small sub-volumes. And then by filling the database of the volumes with the artifacts found, and actually I think now in Stockholm, part of them, it was possible to resimulate a stratigraphic sequence in the cave. This was extremely interesting to show you, to show how technology and the combination of these things can really allow you to reopen cases which before were considered completely closed. And it's not only about flat volumes. It's not about volumes of what was lost or what you can see. Volumes allow also to map space which is intangible. And most important, we use very much a technique based on vector volumes. There is a motive behind of it, because the majority of acquisition techniques like laser scanning, for example, or image-based modeling, they come out with a point cloud. And the point cloud is very light to be visualized. So if you transform actually that point in a small cube, basically what you do, you are adding a volumetric volume of everything is in the specific space. And it's interesting because allow you to, for example, making visual scape analysis in a completely different way. I mean, measuring what is actually not material, what is in the interspace, where people were moving, the people were living. This, by the way, is a fantastic work of one of our students, Victor Lundström, and we made an excavation and calculation of visibility with it. So it's extremely interesting, the potentials which open behind the traditional methods. So how do you stratigraph? What is the stratigraphy in this? Where it is? So it's extremely interesting to expand a little bit the concept of stratigraphy, I would say, and thinking a little bit, let me say, out of the box. Now we'll present some case study, and I want to present some also, no limitation, but something that we have to take into account when we design this. I'm very happy of the presentation before about, there was a mention of Çatalhöyük and stratigraphy, because this fit very well. However, Çatalhöyük, you have usually 100 or 150, how many archaeologists working in the field and acquiring a lot of context about it. I mean, you cannot really make a 3D model for each context. We tried, but it was not really easy to manage. So you need to find compromises. And compromises, of course, mean that you say no to some things, but if you're very clear what you want to achieve with it, is it extremely interesting. So we start actually only acquiring or making a 3D model in that case, when we have basically a building which was in phase, a building which was a feature, or a space. It was extremely interesting because 2015, this feature, which now is very visible, but it was not, it came out from one of the walls, which, by the way, in a feature things is basically usually documented by two contexts, right? Bricks and mortar. So, and when this, which was not visible actually in the wall, went to the conservation lab, it came out to be F666, I think, the beast. It's an obsidian, it's a beautiful artifact with obsidian eyes. And the big question is where it was looking at. One of our colleagues, she found actually the feature in one of the old models. What was the problem? The problem was that this feature was covered, was plastered, so we didn't see the eyes. So by making a 3D model of it and realigning the restored feature we need, it was actually possible to, by looking at the line of sight, by looking at the line of sight, it came out a niche, and also another part of this small monument in the house was recognized after all. So you see how this allow you to go back in time and recomposing like a puzzle of this and reinterpreting or interpreting this in a completely different way. It's no longer linear at all. This is another very fun case study. I was involved in a Sandbyborg. It's a ring fort in Holland. And this was an excavation managed by the Kalmar County Museums, and Lund University had the participation of it. And it was a cold case. Basically, it was an homicide in the Iron Age. It was interesting because due to a looting, a small excavation was done, you see A, B, and however, it came out a body and a piece of another body. So basically, the material was removed, 3D model was done, and the year after, a larger excavation was removed. Everything was georeference, everything was in the context. So it was extremely interesting to basically being in the field or having the excavation in your hands and just drag and drop from the geodatabase the models which were merging. So it was possible basically to recreate, to manage in 3D entirely the scene. I think this is already a result, but it was not the result of this paper. At that time, I was working with a colleague of mine. She was doing the PhD, Ellen Deal, so now she doctorated a couple of years ago. She's an osteologist. So we say, why don't we combine all this? Why don't we work together on this? So, and it was extremely interesting because together we customized the database in order to actually host the information from osteology. And what she did, instead of when she was analyzing bone by bone in Lund, she was recording in 3D directly on the bones the typology of the osteological analysis, of fractures or whatever. And by just querying the system and saying, show me all the fracture post-mortem, it just came out this, which is a pattern, meaning probably the roof collapsing on the bodies and cracking the bones. This was interesting. Why? Because if you look at experimental archaeology, if the building would have been left there, the tiles would have been falling like that, not creating this pattern. So it was telling us that actually it was collapsed in the very same moment or immediately after they died. The bones would have been spread out. And so this was also, by the way, giving information about, I would say, the roof and the house. So it was extremely interesting, the fact that this information was not possible to identify. It was not impossible to identify neither in the field or in the lab. And this is important, especially with the first presentation about, in a microscopic way, how much we can see. It's true. Another question is, and which kind of environment will allow me to see this? Because it's not only a limitation of our eyes in detecting or not an information, but it's also the limitation of our mind in putting together the piece and identifying the patterns. And it's great because actually we're now collaborating with the forensic police. The Swedish forensic police was very interesting in this technique. They probably got the paper, so we pull up a project together in a national grant infrastructure. And we are having a lot of meetings because we think we can learn a lot from each other. And they have a lot of, things or approaches which could be interesting for us. So this is very important because it shows how, thinking out of the box or trying to make something different or challenging the paradigms allow you eventually to have actually strong impact also in the society. And by the way, receiving from the society an interesting impact. This is the last slide. I'm very proud. It was only 18 minutes. It's to summarize not the problem, but the situation. Really going through that I designed the best software of 3D visualization ever, or you should not use that, you should not use that, or the database should be done only for this and only for us. Yes and no. This is absolutely true. We need to implement tools. I absolutely agree with it. But we also need to account that it's not the tool per se. It's also the way of how we combine all these tools for answering the research questions. When we work in Pompeii, for example, the database, the visualization system and everything was done to answer questions which are typical of Pompeii analysis. When we were looking at Dell'Unto, it was completely different. Same tools, same archaeologists in a sense, but very, very different. So the point is, let's keep being flexible. And because this is actually flexibility, I think is the key word with the new upcoming technologies, and will give us the possibility of doing so much more than what has been just done. So